In Cobweb market situation, the output decision of the producer depends on the price of the previous period, and the demand for products depends on the price of the current period. Therefore, in case of linear demand and supply function in Cobweb market model, the quantity demanded QD is equal to A minus BPT, where PT is price of the current period, and the quantity supply QS is the minus C plus D PT minus 1, where PT minus 1 is the price of previous period. QD is equal to QS. Here B is the slope of demand function and D is the slope of supply function. Demand equation, supply equation and market equilibrium equation is considered as equation number 1, 2 and 3 respectively. Substituting equation 1 and 2 in equation 3, we get A minus BPT equal to minus C plus dpt minus 1. After simplification, we get pt plus d by b pt minus 1 equal to a plus c divided by b. Shifting the time subscript ahead of one period, we rewrite the equation as pt plus 1 plus d by b into pt equal to a plus c by b. So this is equation number 4. Since the equation number 4 has the time lag of one period, so equation 4 is the first order difference equation. We know that the solution of the first order equation yt plus 1 plus a into yt equal to c is yt equal to y naught minus c divided by 1 plus a into minus a whole to the power t plus c divided by 1 plus a. This is the general solution of this first order difference equation. Similarly, the solution of equation 4 is pt is equal to p naught minus a plus c divided by b divided by 1 plus d by b into minus d by b whole to the power t plus a plus c divided by b divided by 1 plus d by b. In place of c in equation 4, we have a plus c divided by b, and in place of a we have d by b. After simplification, we get pt equal to p naught plus a plus c divided by b plus d into minus d by b whole to the power t plus a plus c divided by b plus d. So this is equation number 5. Since p bar is equal to a plus c divided by b plus d is the intertemporal equilibrium price, we rewrite the equation 5 as pt is equal to p naught minus p bar into minus d by b whole to the power t plus p bar. This is equation number 6. The equation number 6 is the time part of the Cobweb market model. Here, P naught is the initial price and P bar is the intertemporal equilibrium price. Now, the nature of time part of PT depends on d by b, that is the ratio of the slope of supply curve d and the slope of demand curve b. Depending on the value of d and b, we may have three cases. Case 1, if b is greater than d or the slope of demand curve is more than the slope of supply curve, then d by b is less than 1 or a fraction. In such case, as the value of t is increasing, then the value of minus d by b power t is falling, or as t tends to infinity, then minus d by b whole to the power t tends to infinity. Since d by b is a fraction, so as the power of a fraction increases, then overall value decreases, and so as t tends to infinity, then minus d by b whole to the power t tends to 0. If minus d by b whole to the power t is becomes 0, then in equation 6 pt will be equal to p bar, that is, with the passage of time pt tends to p bar. In such case, the time part is convergent and the market is dynamically stable. Diagrammatically, the horizontal axis is a curve for demand and supply, and vertical axis indicates price. DD is the demand curve and SS is the supply curve. P bar is the equilibrium price, where D is equal to S, that is, demand is equal to supply. If the initial price P0 is more than P bar, then this excess supply brings down the price to this level, which is lower than P bar. Again, this excess demand will bring up the price up to this level, which is more than P bar. Again, the excess supply force will bring down the price, and this way the price will be adjusted with the P bar or equilibrium price. So in case of conversion time part, the price level approaches to the equilibrium price P bar. Happens when D by B is less than 1, that is, if the slope of demand curve is more than the slope of supply curve. Case 2. If B less than D, or the slope of demand curve is less than the slope of supply curve, then D by B is greater than 1 or more than 1. In such case, as the value of t is increasing, then the value of minus d by b power t is increasing, or as t tends to infinity, then minus d by b whole to the power t will also tends to infinity. If the value of minus d by b whole to the power t is increasing, then in equation 6, the current price Pt will divert more and more from the equilibrium price P bar, and so the time part is divergent and the market is not dynamically stable or dynamically unstable. Diagrammatically, in case of divergent time part, if the initial price P naught is different from the equilibrium price, or if there is a divergence between equilibrium price and initial price, then the divergence will go on increasing with the passage of time. The price will be diverted from equilibrium price, and it is called explosive market price. Case 3. If B is equal to D, or the slope of demand curve is equal to the slope of supply curve, then D by B is equal to 1. So in such case, as the value of t is increasing, then the value of minus d by b power t is alternatively plus 1 and minus 1, depending whether t is even or odd. And in equation 6, the difference between Pt and P bar is remain the same, and the time part is said to be regular. Diagrammatically, in case of regular time part, the difference between initial price and equilibrium price P bar is remain same with the passage of time, and it happens when d by b is equal to 1 or the slope of demand curve is equal to the slope of supply curve. Hope you have understood the nature of the time part of Cobweb market model. Thank you.